Hi, in this course on basic construction materials, today we will look at aluminium and copper and their production, properties and uses. In the other lectures, we have covered iron products, steel and then steel reinforcing bar, also structural steel, and then now looking at aluminum and copper and production, properties and uses. Okay, so these are the some of the books used for this course, and of course we have used a lot of material from the internet. Now, the production of aluminum, mainly what is the raw material which is used? It is nothing but bauxite. Okay, so bauxite is used and then it is crushed into smaller size and then it is dried after mixing with water, and then you have further mixing processes, digestion processes and then filtration, etc. And then eventually it is heated, the material is heated or calcined, and then finally you get the molten aluminum, and then it is made into different poured into different casting molds for the purpose of further usage. So, this is the brief on how aluminum is produced. You can just pause for a few minutes and then look at various processes involved here, but not necessarily, we do not need to go too much into the detail on this particular course. Okay. So, let us very briefly look at whatever we just discussed on the production of aluminum. First step is alumina is chemically extracted from bauxite. Now, what is there in bauxite? It is basically a mixture of hydrated aluminum oxide and hydrated iron oxide, and there are also other oxides present in that ore like titanium oxide, etc. are also some silica, etc. might be present in that ore material which you collect. And then this is our key element here, aluminum oxide. Okay. Then this alumina is then further reduced to aluminum. So, alumina is from this, it is reduced to, you are extracting the metal aluminum. So, when this process requires a lot of energy, and how much is that? It requires about, let us say 13,500 DC kilowatt hour, that much is the power requirement. So, it is very energy intensive process to produce just 1 ton of aluminum. Okay. Now, let us look at the other waste which is generated during the aluminum production. About 4 to 5 tons of bauxite, if you take 4 to 5 tons of bauxite, and that is required to produce 2 tons of alumina. So, you can see from 4 to 5 only 2 tons of alumina you are getting, from which eventually you get only 1 ton of aluminum. Okay. So, 1 ton of aluminum is produced from about 4 to 5 tons of bauxite. So, what the remaining all waste, that is let us say if I take 4 from 1 ton of aluminum, if I am assuming that 4 tons of bauxite is required, that is only 25% of the material is actually the final product. So, you have 75% of the material as byproduct or waste. Okay. And this red mud is a either we can look at it as a waste product or byproduct, but mostly waste product because it is not really being used today, it is actually ponded. So, I will show you some photographs. So, main point here is there is lot of waste generated with the production of aluminum. You can watch this YouTube video on this production process also. Now, for every ton of alumina produced, the process can leave behind a third of a ton to more than 2 tons of lot of waste. That is the whole point. You can look at these numbers more specifically, but the Odisha is the state where in India we have a lot of aluminum production happening, and there are a lot of ponds like that. You can see this, the aerial view taken from aircraft or a helicopter. You can see this is the pond. So, you can see the size of that large waste where it is dumped, or the red mud pond. Okay. Now, what is the problem with this red mud? The first thing is it is a rusty in color because of the presence of iron compounds, okay, but that is okay, color does not matter much. But this is the problem, it has a very high pH. Now, when you have very high pH and you have a pond like this, imagine that bund or the barrier of this pond, it breaks, or the dam breaks, and then this material just starts flowing outward, then that is very dangerous for all the things which are around that pond. Okay, so that is one danger thing about this. So, it has high pH. So, now people have actually started looking at whether this can be used for road construction. Okay. So, red mud is actually used for road construction. There are examples where people have used, or basically concrete, okay, red mud, concrete made of red mud. So, this is an upcoming research area also, if some of you are interested can look at that aspect. So, this waste, like the fly ash waste which is there in the power plants, people started using fly ash for concrete making, right. So, similarly, now there is a lot of research going on in looking at the use of red mud in concrete construction. Now, primarily aluminum is used for containers, packaging, aircraft, automobiles, etc. Now, in civil engineering, where do we use? Use for architectural and finishing elements like doors, windows, siding, with a small amount used for electrical wiring also. Okay, you can see that that is also, but the volume wise, if you look at that, electrical wiring may not have significant volume, but other elements like doors, windows, if you look at it, there is a large quantity of aluminum being used. Now, these are not very much used for structural members, but now we see that mainly all this light, wherever you want a light element, we are still trying to use it, but structural members still not, because of mainly because of the cost associated with it. It is very expensive, okay, and strength and ductility, strength is not as high as steel, okay, ductility, elongation wise yes, but because strength is not that high, then it has big limitation when it comes to structural element. And coefficient of thermal expansion is also another reason why we cannot really use it in concrete, etc. Now, these are some of the examples to show you where the aluminum is used in civil engineering construction. Okay. So, these are just first picture on the top left, this is just some frame structures, etc. which may not have very high structural strength requirement, but so in other cases small loading capacity things we can make with aluminum. Okay. Then wall elements, you can see here these channels, these channels which are being made, and then for electrical wiring, these wiring, I am not talking about this pillar, this is not aluminum, that is definitely steel. But what we are talking is these wires, this electrical wires, these are made of aluminum. Okay. So, this. Okay. So, we are talking about this electrical wires or transmission lines, that is what that is made of aluminum. Then also different type of sections or channel section, different shapes for making complex and architecturally aesthetic doors, windows, frames, etc. aluminum is used. Also in the fence sometimes aluminum, but this galvanized iron is also widely used. And this is another place where if you talk about the facades of buildings, there you can see these channels are first placed on top, you will get glass facades. So, that those channels are also made of aluminum. So, there are various places where aluminum is used, may not be necessarily as a structural element, but there are other places where it is used. And use of anodized aluminum. So, this anodized aluminum is something which is more corrosion resistant, and at the same time it looks very you can have different color to it. It is not just a painting, the one on the right side or left side, these are not colored aluminum, but these are like a painted aluminum, these are colored, but not by painting, but by a process called anodization. I'll cover that process later, but for now you understand that some of the time when you visit places, you will see these different door frames, etc. You might look for, is there aluminum being used in that? Okay. So, sometimes there will be plastic coating, like this one here, you will have plastic coating on the bottom right image, plastic coating, but inside that there may be aluminum elements which are used mainly for ensuring that the strength, etc. But at the same time we need a material which is corrosion resistant also in such cases. So, corrosion resistance is one good property, and also in this anodized aluminum you can have different colored elements for artistic or aesthetic purposes. So, let us look at some of the advantages. Most plentiful metal on earth, it is abundantly available in many places, and density is 1/3 that of steel. So, it is lightweight, that is why people actually prefer to use it, even though cost is high. But then high strength to weight ratio, that means for a small particular section I can have more strength with less material being used. That is the idea of that. Definitely it has high corrosion rate, and then next point is good. And how this corrosion rate is reduced? I am sorry, I told high corrosion rate, it is high corrosion resistance, or rather low corrosion rate. Okay. So, how is it achieved? Corrosion rate is reduced because, or is less because, the oxide film which is formed on the aluminum surface, this one, it is Al2O3, which is much resistant against, or which can resist the entry or availability of oxygen and moisture to the layer below that. Okay. So, it protects the metal or the bare metal below the oxide layer, whereas in case of iron or steel we have this oxide layer of iron. However, we have seen many places steel actually corrodes. So, the resistance of aluminum against corrosion is higher than that of steel. So, if you have a highly corrosive environment, it is better to use aluminum than iron or steel. Okay. So, that also adds value to the use of aluminum, especially in the long run. Now, good thermal and electrical conductivity, that is also very good. So, because of high electrical conductivity, we are able to use as electrical wires for transmission lines, etc. And anodizing or hard coating, this is possible with aluminum. We can provide an aluminum oxide layer on top. I will cover that process later, but that is also a possibility, and which gives the high hardness to the surface and also color as we want, and it is corrosion resistant also. Now, high reflectivity, because of this white or grayish color, it reflects the sunlight. Okay. So, it does not absorb the radiant heat. Then non-toxic and not attacked by insects like wood or anything, if you want to compare. So, for doors and frames, if you have wooden door and frame, there are possibilities of termite attack, etc. But if you go for aluminum frame, you can forget those options. I mean forget those kind of problems in the long run. And for maintenance also, it is relatively easy, mainly because it is lightweight and then easy to work with, etc. So, easy to work with and easy to recycle. So, this material is very sustainable in that way. You can remelt it and produce another product. Okay, just like steel. Steel is also easily recyclable. If you are able to collect it, you can use again for making new steel. And like I mentioned, in the some countries abroad, 90% of the steel is made by scrap steel. Okay. Now, let us look at the stress strain behavior of aluminum. So, you can see here this thick black curve, this curve here. Okay. Now, you have this curve is strain versus stress. Okay. So, the stress strain. Now, when you take 0.2% offset, if I draw a parallel line like this in this thing, you are getting a proof stress of about 35 KSI. Okay. Now, how do you convert that KSI to GPa or MPa? The equation is given in the blue thing here, 007 GPa. If you want to convert KSI to either MPa or GPa, you can look at these conversions. Okay. So, yield strength is this, and one thing to note here is there is no definite yield point, no, it is like very gradually it is changing. Okay. That is a particular feature of aluminum. When you have mild steel, you do not get like this, no. In the case of mild steel, you will have a curve which goes and something like this, and then it goes like this. So, this plateau region is missing in case of aluminum, especially if you are talking about aluminum alloy, you will see only like very gradual change in the stress strain, the slope of the stress strain curve. Okay. So, in case this is for steel, in particular mild steel, and this is my this is the yield point. Okay. Yield point. Okay. So, what is the typical ultimate tensile strength of aluminum? It can range anywhere from 100 to 550 etc., depending on the type of alloy you are talking about. Modulus of elasticity, it can range from 70 to 79 or let us say 80. That is a typical modulus of elasticity which you are talking about. Now, let us look at a comparison here. So, in case of aluminum alloys is like this. Let us say for steel, what will be? For steel, you can have tensile strength, ranging from 250 to 600, 700 like that. This kind of steels are available. If you are talking about pre-stressing steel, it is 1860 like that. So, very large, this is not ultimate. I am talking about this is yield strength. Okay. Now, modulus of elasticity E of steel, it ranges from about we typically assume the number 200 GPa. Okay. This is what typically we assume for modulus of elasticity of steel. Now, modulus of elasticity of aluminum is 70 to 79. So, it is much less. So, this both the tensile strength, yield strength, modulus etc. are less for aluminum. So, we have to think about that while suggesting it for some use. Now, what about the effect of temperature on the strength of aluminum? So, let us say for typical environmental temperature condition, let us say 0 to 50 degrees Celsius, you do not see much variation, it is okay. But if the temperature goes let us say 100 plus etc., for why this is important is this kind of limits the use of aluminum for many of the chemical plants etc., where you can have fluid with high temperature going etc. So, this kind of limits some of the applications. So, there is a significant reduction in the properties after about let us say 100 degrees Celsius or something. So, you have to look at when you suggest to use aluminum for some whatever purpose, you have to think about the temperature effects also. Okay. Now, cross sectional dimension of steel and aluminum beams considering equal deflection, considering equal. So, this is a beam you can see on the top right, it is a beam with a height of the cross section h and width b, okay, and length of the beam is considered to be 2x. Now, if you apply a load W at the center, okay, then I can calculate the deflection as using this formula. Deflection at the center I can calculate using W multiplied by length to the power 3 divided by 48 EI. What is EI? E is the modulus of elasticity and I is the moment of inertia. Okay. So, this if I say for aluminum I am going to call EA and IA, and for steel ES and IS. Okay. Now, if you compare that, so this equation I can make this equation by cutting this 48, 48, W, W, this thing. So, I can say that EAIA is equal to ESIS. Now, what is I? It is a rectangular section. So, I can say I is equal to, for rectangular section, BH cube divided by 12. Now, from that, if I substitute that into this, if I substitute this into this, okay. So, I can get this equation, which where I say width of the aluminum that section required will be something like this. Now, let us look at these numbers. Okay. If HA is equal to HS, or in other words same height we consider for both steel and aluminum, then assuming the modulus of steel to be 200 and modulus of aluminum to be 75, what we eventually get is BA is equal to 2.7 times BS. That means this term here is equal to 2.7. Okay. So, what does this mean? If I replace a steel section with aluminum section, I will have to go for 2.7 times the width. So, aluminum section will be almost 3 times more in volume. Okay. So, that is one reason, and also it is costly. So, it is not really good because not really good for structural applications. Okay. But there are many other applications where structural means large beams, large columns, wherever you put, like in railway stations, etc., you will see steel truss members, etc. There you cannot go for aluminum because you will need much more material. But there are so many other places where doors, windows, frames, etc., etc., where we can use aluminum for construction purpose.